Hey, thanks for coming. So for those of you that don't know, I work at a company called 3Box Labs, which makes a product called Ceramic. And I'll be talking about how you can have mutable content for your centralized applications. So if we go back in time and think about the promises of blockchain, it was to solve exactly this, to not have these centralized data silos of big tech companies, and to have a more egalitarian society of data on the internet that probably resembled more of this than those big tech companies owning everything. But the question I'd like to ask you all is, have we achieved this dream? And I think the answer is clearly no. I think we look more like a picture on the last slide, but replacing the tech companies' names with blockchain names, and maybe some storage companies. So this is how most centralized applications look today. You have essentially silos of user data. You have user's wallet, their smart contracts, maybe IPFS or Arweave or SIA network or any other decentralized storage, backend, and a user table. And this is a problem because data is often still siloed between applications or even between blockchains on the same blockchain. So I'd like to propose a way to change this, to solve this problem by having data be more distributed and shared between applications. If we go way back in time, you can think about the innovation that blockchain had, this agreement on central state, enhance peer-to-peer communications, but the main problem is it's difficult for all data. And you may be saying, wait, we're at a conference on Solana and I can store a ton of data because it's so fast, which is true. But you might not want to store all your data on chain, and for most blockchains, this doesn't work quite well. So going a bit forward, we can look towards some of the data shapes that have existed in decentralized applications. On the top left, you'll see Merkle trees, which were used in Bitcoin and many other chains since then to represent hashes of data. On the right there, you'll see a graph that represents Git data, this kind of graph of different commits and pieces of data that are linked together. But the key insight here is that all of these can be represented as a DAG, directed acyclic graph, and more specifically, a Merkle DAG. And the codec that we use to do this is called IP length data. That's what IPLD stands for. It was pioneered by the Protocol Labs team responsible for IPFS, and this is how they encode their data, and their codec is really the key that makes this concept possible of sharing data across different chains and across different storage networks. And one of the insights here is that you'll see there are different color boxes for different data types. You associate a schema, a data shape for each of the data types, and as long as they encode to this graph, you're able to link them together. So if we now look at sovereign data, we want two key properties. We want cryptographic verifiability, whether it's a file on IPFS, a contract on Ethereum or Solana, and maybe a token. But we also want mutability. But in that mutability, we want a consistent way to reference the data and have it really scale, and also a transparent way to see who controls what data, who's able to read, write, or execute any piece of data. And the end goal is to make the internet verifiable by combining these properties. So today there are two key classes of solutions that try to address this. Some are based on public keys, controlling what happens where. The Protocol Labs team has IPNS, which is a way to associate a key pair with any set of data, set of hashes that are on IPFS. Secure Scuttlebutt and others do similar things. And then the second class are more like state machines that just store event logs. And this is a way to link data together in a decentralized way, but none of them really combine both of them, which is key to anchoring to the blockchain. Enter Ceramic. So Ceramic's innovation is to have mutable data objects as a primitive, and that means having an audible commit log. You see each change revision to the data, much like Git. And the event processing can represent the state, whether it's the sum or just the head or any specific commit you can access. And we're built on top of a W3C standard that's up and coming called Centralized Identifiers. We've been actively involved in the W3C, Centralized Identity Foundation, and a few other standards bodies to help work on this technology. But what a decentralized identifier is a way to represent multiple keys and the changing of keys over time. So you might think of your identity today as your Solana address or your Ethereum address, but that's pretty fragile because you're associating your identity with all your financial information. So you might often want to have multiple addresses associated. You might want to have key rotation. You might want to have more traditional security controls that is quite limiting by what's available by single addresses today. So DIDs are a way to link together multiple blockchain addresses and even change them over time while having a persistent identifier. And mutable pointers, this is a key, so you can have what we call a stream of data, which is that essentially commit log, where you can see what's the latest state or any reversion, and you can see who authored the data at any point in time, in addition to seeing the state of the DID document, a decentralized identity document that corresponds with the stream and commit at any point in time. And we have a top-level concept called stream types, which you can think of as data types. Right now we have a few key ones, but you might imagine different streams to store like key values or lists or Merkle DAGs or any stream type of data that you are interested in. I won't go into too much detail here, but the guts of Ceramic kind of look like this. You have a signature for some data. You write that data to any object storage you want, whether it's Arweave or Filecoin or S3 if you want, and you bring your own key from any blockchain, or it doesn't even need to be a blockchain. And at some point in time, we checkpoint that data to a blockchain. This is our current architecture. We're kind of migrating away from this, so it's a bit more flexible, but the concept is store your data where you want, use the authentication that you want, and have really high integrity as your data changes. So what can you do with Ceramic? I don't think we're quite at the point where all the potential has been realized, but we're starting to see some really exciting applications. And the first is the vision of a unified user identity. If you're on the internet today, you probably have a ton of accounts, whether it's Google, I hope not Facebook, maybe Twitter, Discord, God knows how many others, but there's a problem here because those identities are not your own. They're owned by these third-party companies, and you've probably seen a lot of instances of censorship where these companies shut off people's accounts or limit their controls, and that's not great. So the key that Ceramic enables is something that's more of a global user table. So the DIDs on the left represent different addresses that may be associated with a user, and you can list out all your keys and relations to different pieces of software with really fine-grained access controls. So this inverts the locus of control from all these companies having your information and controlling your identity to you being the source of truth for your own identity. And I do want to mention here that you might not want all this to be public on a blockchain or any storage, and you can encrypt anything. That's something we're working hard on, making it so that you can disclose what you want to who you want, when you want, and still have the integrity guaranteed by blockchain and decentralized file systems. So wouldn't it be great if you only had one identifier that you controlled and you just use this everywhere, independent of storage, blockchains, and centralized corporations? So this kind of leads us to an idea of a decentralized anti-fragile data ecosystem. To give an example, if I have an account on one service and they have an idea of a name as like a string or some text, and another service has an idea of my name, but it's not a string or text, it's maybe like a more complex object that has other metadata associated with it, you can't think of these identities as transferable. You can't bring one to the other because they have different data shapes. But Ceramic insists on using data models, JSON schema, and some other types to make this really strong and say, here is the definition of our person, our name, so it can be ingested into other systems. And tangibly, this looks like assigning exactly the data shape of each entry in a published manner. And this will be a key functionality of Ceramic to have this global table of data models that are used and accepted and become authoritative for different areas of knowledge, whether it's employment history or who a person is or a user account or anything else. And once we have this kind of system, we can really harness the shared network effects of having a global user table. One example I like to think of is preference data relating to movies. You might be on Netflix and Hulu and HBO Max, and each of these services are competing to get your preference data and show you the best movies. And it's really annoying to have to either like things or dislike things or watch a bunch until the suggestions are relevant. But really, it would be best if you were able to share your preference data across all these and you just have better content immediately. But that's a problem that's not solvable today because the data is not yours. And I think we're moving towards this world where instead of competing for retaining users in your user base, in your database, you can retain users by the quality of your service. So that's what this technology enables us to move towards. So the end goal of Ceramic is to unsilo and free humanity's data. And we have a ton of projects starting to build on us across different blockchains and storage systems, and Solana is up and coming, and we want you to build too. That leads me to some developer documentation for our network, which is launched in mainnet as of earlier this year, and we're expanding out more nodes all the time. We have a few hundred projects and ever growing, so please come build with us, both on our network and our identity protocol. And the last thing is we're hiring. So if you're looking for a job or interested, come talk to me or send me a message, and we'd love to work with you. And that's it.